students, today myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So today we will discuss the topic corrosion, and the outcome of this session would be understanding the process of corrosion, the classification, different classifications, and then their mechanism. So here are the topics: introduction to the corrosion, what is a corrosion and all, then factors affecting the corrosion. So what are the factors that really affect the metal for corroding, then types of corrosion, then theories of corrosion. Then these theories are again classified like acid theory, dry or chemical theory, and then galvanic or electrochemical or wet theory of corrosion. So we will discuss all these in detail. So before moving to the actual topic, we should understand what is a corrosion. So it is nothing but the gradual destruction. So the gradual destruction or deterioration of metals by chemical or electrochemical attack of the environment. So due to this effect, there is some degradation of the material, like metals that are used in daily lives applications. So that is nothing but corrosion. So what are the main causes? So generally metals exist in their ore forms. So as we see, the metals are existing in their ore forms before they are purified. So that is a stable form. So that ore form is a stable form. So when during extraction, so when we are extracting metal from their ores, they are reduced to its metallic state. So ores are converted to metals. So this is done by supplying some energy that is required to reduce these ores to metals. So what happens when it is in metal form? It is in excited state. So these are in excited state. So they tend to react with the environment or other affecting factors to form to a stable product. So they want to go back to their stable form always. So this natural tendency of going back to its original state or the stable form of these metals is nothing but corrosion, and that is the corrosion product. So as we see from this figure, see, these are all bearings that are converted into corroded metals that are in stable form. So this is why the metals always tend to go back to their states, forming some corrosion product, which is a stable form of its. So then what are the effects? Effects are the wastage of metal. So for example, if we are using a metal for some applications, then when it is corroded, it will lose its property of that particular application, and therefore there is a wastage of this metal. Then valuable metallic properties like conductivity, malleability, ductility are lost. So as I said before, these metal properties like conductivity or malleability and ductility are lost if they are corroded. So then the lifespan, ultimately it leads to reducing of lifespan and efficiency of metal. So when we are using it particularly for machinery, if in between during the usage, if it is getting corroded, then we ultimately lose the efficiency of that machine. So these are the main factors. The nature of metal and the nature of environment are the two main factors that is affecting the corrosion. So in that we have again some different factors that is affecting. If we consider the nature of metal, so the placement of metal, where the position of metals in this galvanic series, the position of metals in galvanic series is also important. Galvanic series is important because, see, anode, when does it form an anode? When it is highly reactive. When the metal is highly reactive, it forms an anode, and it is a cathode when it is less reactive. So what happens at anode? Oxidation, and at cathode, reduction. So as we see from this series, the active metals are anodes, and less reactive are cathodes. Less reactive are cathode. That is why when we wear gold or platinum or silver, they are less reactive. That is why we are able to wear it even in different environments. So the areas of anodes and cathodes is also important, because cathodic area, if the cathodic area increases, corrosion will increase, because, and if anode area increases, corrosion decreases. So because when at anode oxidation takes place, so when oxidation takes place, when the area is high, when the area of the anode is high, for example, the corrosion area is more, corrosion area is more, I mean the area of anode, for example, anode is more, the corrosion will decrease, because it should be the sufficient reaction has to take place to cover the complete area. So that is why the corrosion will reduce to some extent. Then the purity. High pure metals have less corrosion. This is what we have to understand. Like during any applications in building or machinery or any other applications of these metals, the purity of metal is very important, because which is less reactive and becomes less corroded. And the impurity increases corrosion. Impurity, presence of impurity like oxides or any other gases will increase the corrosion. Then in continuation, we will see what is the effect of nature of environment. So nature of environment is also very crucial to understand, because with increase in temperature, when there is an increase in temperature, the corrosion increases. The corrosion increases. When there is increase in temperature, corrosion increases. Corrosion increases due to the rate of diffusion ions, because the rate of diffusion of ion increases, so the corrosion also increases. Then humidity and moisture. What is the effect of humidity and moisture? These humidity and moisture will act as a solvent for carbon dioxide, oxygen, carbon dioxide and sulfur dioxide. These are some of the gases. So for these gases, this moisture and humidity will act as solvent and produce electrolyte. So in this presence of these all materials, it will undergo corrosion. So as we see from this figure also, all these gases come from atmospheric pollution. So pollution causes these gases to help in corrosion. So these are some of the effects. Then pH. The lesser the pH, the greater will be corrosion, because at less pH it acts as an acidic medium. So in acidic environment or acidic medium, the corrosion will increase as the rate of diffusion of ions also increases in acidic medium. Then presence of impurities and suspended particles in the atmosphere. So these impurities and suspended particles like air or any other gases acts as like a medium, and these vapors of acids, corrosive gases like carbon dioxide, sulfur dioxide, hydrogen sulfide and vapors of acids increases the electrical conductivity and thereby increase the rate of corrosion. So as we discussed before, these vapors of acids or any gases will act as a medium for corrosion. So there are different types of corrosion. We are seeing to corrosion, but at what condition the corrosion takes place. So in the depending on the condition or the environment, there are two types of corrosions: dry corrosion and wet corrosion. So what happens in the dry corrosion? It occurs in the dry condition, and in wet corrosion occurs in the wet condition. So in dry condition, if the corrosion takes place due to direct chemical attack, so there is no need of any moisture. So the corrosion will occur in direct chemical attack in the absence of moisture. This corrosion is known as dry corrosion. And what happens in the wet corrosion? It occurs in the presence of moisture. So if the corrosion takes place due to electrochemical attack in the presence of moisture or a conducting medium, in the presence of moisture or a conducting medium, then it is a wet corrosion. So it is explained by dry corrosion is explained by absorption, because we have some corroding metal by metal. So there is some chemical attack. So it is going to corrode the metal. So what happens? What does it really happens? There is some chemical that is going and absorbing on the metal. So this absorption will cause corrosion. So that is why the mechanism all depends on the absorption capacity of that metal. Then wet corrosion is explained by electrochemical mechanism. A wet corrosion occurs by electrochemical mechanism. For example, if we see the silver spoon, this silver spoon is corroded, tarnished silver. So what happens here? There is some gas like oxygen. It will react with the silver and forms silver oxide. So this is the corrosion. And wet, what happens? It is this bar, a metal bar is in contact with the solvent. Here it is water. So it forms an anode or cathode, and it depends on the electrochemical reactions that is taking place. That is why it is wet corrosion. Then dry corrosion occurs in both heterogeneous and homogeneous surface. So when there is a metal, even if it is heterogeneous or homogeneous, dry corrosion occurs, because it is only like absorption ability of that metal for a dry corrosion to take place. However, wet corrosion occurs only at heterogeneous metal surfaces. It means it should have the ability to form an anode or cathode. So it requires two non-uniform or dissimilar metals to be in contact. So that is nothing but heterogeneous metal surfaces. So the dry corrosion is uniform. So I have already shown the spoon, the corrosion on the spoon is uniform. It is like the absorption is uniform and the corrosion is also uniform. And the wet corrosion is not uniform. So wet corrosion is not uniform. If we see here, the bar is corroded till here only, and it is not uniform also. There are some gaps still. So it is not uniform. This is a slow process. Dry corrosion is a slow process, whereas wet corrosion is a fast process. So because of this anode and cathode formation, wet corrosion is faster than dry corrosion. Then the corrosion products accumulates at the place where corrosion occurs. So wherever there is absorption of any particle, then the dry corrosion occurs, like chemical attack. So the corroded products will be accumulating on the place where the corrosion takes place. But in the case of wet corrosion, the corrosion takes place at anode, but the products are near the cathode. So we will see in detail how these mechanisms are going on and how the corrosion will take place. So there are different theories of corrosion that will explain the corrosion mechanism. So there are basically three theories: acid theory of corrosion, then dry or chemical theory of corrosion, then galvanic or electrochemical or wet theory of corrosion. So these are the three different theories that explain the corrosion of any metals. So the first one is the acid theory of corrosion. In acid theory, what happens? For example, corrosion of a metal is due to presence of acids. So as the name indicates, acid theory, presence of acids. So it either becomes an acidic medium or the presence of acid around the metal. So according to this theory, iron is corroded by atmospheric carbon dioxide, moisture and oxygen. So this presence of, for example, iron, if we take, there is an iron bar, and if, for example, if there is an atmosphere of carbon dioxide or moisture or oxygen. So from this figure we can see that there is some oxygen that is going and reacting with the iron metal. So the corrosion products that will form are iron bicarbonate, then FeOH CO3 like hydroxycarbonate, then ferric ferric oxide. These, so there are some reactions in continuous reacting with the oxygen. There is a formation of rust ultimately, that is nothing but ferric hydroxide or oxide. So iron, when it is reacting with carbon dioxide, water and oxygen, this forms bicarbonate. This forms bicarbonate. Then in continuation reaction with this water and moisture and oxygen, here water is nothing but moisture. So with reacting with continuously reacting with water and oxygen, it forms hydroxycarbonate and then ultimately the hydrated ferric oxide, which is nothing but the rust. So what happened in this theory? It is giving an environment containing acid. It is giving an environment containing acid, nothing but acidic nature due to carbon dioxide and moisture. So in the second theory, dry or chemical theory of corrosion, what happens in this? So the theory states that corrosion is due to reaction of atmospheric gases. So in this, chemically it will be attacked by the gases and undergoes dry corrosion. So oxygen, halogens or sulfur oxides are some of the examples like they react. So here what happens, for example, if we see this example, there is a lock on the door, so that is corroded due to oxygen reaction. So reaction with oxygen, so the copper is turned into greenish. Then the other example is SMD resistor with silver disulfide flakes of the silver. So the silver is converted to silver disulfide due to hydrogen disulfide gas. So these are some of the good examples. So this, when it is corroded like this, it is really affecting the electronics. So there are some different types of dry corrosions depending upon the gases that are reacting. So oxidation corrosion due to oxygen, then corrosion by other atmospheric gases other than oxygen, then it is atmospheric gases, then liquid metal corrosion that causes dry corrosion. So if we in detail, if we go to oxidation corrosion, what happens? The oxygen present in the atmosphere will react with the metal, so forming some oxide layers. So ultimately it forms some oxide layers. So for example, if we have a metal, it is undergoing oxidation like Mn2 place and gives off 2 electrons. This is oxidation. So the mechanism is like for example, this is the metal. We have metal atoms. These are the metal atoms. So these are the oxygen molecule atoms with some bonds. So this O2 oxygen reacts with these metal atoms. So what happens? First it absorbs on metal. Then what happens? Dissociates. This oxygen will dissociate to oxygen atoms. So these atoms will then lose electrons. The loss of electrons by metal. So these metal will give up some electrons, Mn2 plus 2 electrons. These 2 electrons will combine with the oxygen. Loss of electrons by metal atoms gains electron by oxygen atoms. So this continues. This will continue, keep on continuing and form some layer. This is same thing we have to understand from the reaction mechanism, where this oxygen will take up these 2 electrons and give reduces. Then this will ultimately again and reacts again and again and forms a metal oxide. Layer. So this is some example. Oxidation of brass. So without corroded, non-corroded metal. This is corroded. So as we see, there is some greenish or bluish green colored deposition on the brass, which is nothing but the oxygen layer, oxide layer. So nature of oxide is also very important. When oxidation starts, a thin layer of oxide film will be formed on surface, and nature of film decides the further reaction. So if the reaction, if the process, the formed layer is porous or non-porous, depending on that, the further reaction will take place. So that we will see in detail how the different oxide layers will facilitate the corrosion. So oxidation, the nature of metal oxide, as I said before, it is very important. So if it is a stable metal oxide layer, what happens? Then it forms a fine grained structure and get adhered tightly to the metal parent metal surface. So the fine grained one will adhere tightly to the metal surface. So this is how it is, like it is forming a metal oxide layer. So this behaves as a protective coating, like it will avoid the further corrosion of that metal. So example is like aluminium, antimony, lead and copper. For example, as we know, aluminium, once it forms aluminium oxide, it doesn't react again. So that itself acts as a protecting layer for avoiding further corrosion of that metal. Unstable metal oxide. So what happens in the unstable metal oxide? The oxide layer formed decomposes back to metal and oxygen. So it is unstable. By the name itself, we should understand that metal oxide layer that is formed is unstable. So it will go back to metal and oxygen. So examples are silver, gold, platinum. So they do not undergo oxidation, corrosion. So it will not proceed further oxidation of anymore, like further oxidation or corrosion. So then volatile metal oxide. So what happens in the volatile metal oxide layer? Oxide layer is volatile. Volatile is like evaporating. It evaporates. So which is in nature evaporates, and thereby leaving underlying metal exposed for further corrosion. So in this, for example, molybdenum, when it is exposed for atmospheric air, it gets oxidized. So for metal, then oxygen, it forms volatile metal oxide. So evaporating, this layer gets evaporated. So again the metal is exposed to further corrosion. Example is molybdenum trioxide. Porous metal oxide layer. Then porous metal oxide. If the metal oxide is porous, for example, metal layer is forming which is porous, it has some porosity or holes, the feasibility of oxygen to go, then it contains a crack. So the atmospheric oxygen penetrates and corrodes the metal. So there is always scope for the oxygen to penetrate into the metal and corrodes further. So example is lithium, sodium, potassium and magnesium. So these alkali metals have a high corroding ability due to the formation of porous metal oxide layer. Then the corrosion by other gases. The other one is corrosion by other gases other than oxygen. So what are the other gases? Chlorine, sulfur are some of the gases that undergoes help in corroding the material. So for example, if it is a non-porous, again if it is non-porous layer, sulfide layer for example, or a chloride layer, if it is forming, if it is non-porous, it acts as protective. So example is chloride film is non-porous and chlorine does not pass and no further corrosion occurs. So here if we see silver and chlorine gas is reacting to form a silver chloride layer which is non-porous. So it acts as a protective layer. That is how we have to understand like porous and non-porous. The nature of this layer is very important in both the cases of oxygen and other gases also. So if it is porous, what happens? Again, the non-protective layer forms, like it will have gap or spaces to pass the gases. The gases will pass and continues the corrosion. continues the corrosion. For example, in petroleum industry, the hydrogen sulfide gas pass at high temperature and reacts with steel, forming iron sulfide scale. So this is one of the example where when there is a use of steel in the industry, and there is also a use of hydrogen sulfide gas, then we should be careful like handling the both of them together, because at high temperature it will react with the steel and forms iron sulfide scale. Scale is nothing but deposition layer. Then this is how, see for example, if it is SS key, so it is forming a iron sulfide layer. The black deposition is nothing but iron sulfide layer. Volatile layer. Then in volatile layer, what happens? The metal, whatever the metal gas that is reacting will evaporate. For example, tin and chlorine. It forms tin chloride. So this tin chloride layer will evaporate. So again, it exposes the fresh layer of the metal to the air, and therefore it occurs. There is an occurrence of corrosion, fast corrosion process. Because it is volatile, it will form and evaporate. Then it has scope for the metal exposure. Then the liquid metal corrosion. There are some of the metals which are liquid in state at room temperature, like gallium or mercury. So these forms, for example, mercury forms amalgams for any metals. So at room temperature they are in liquid state. So occurs due to action of flowing liquid metal at high temperatures on the metals or alloys. So this will takes place at high temperature, because the rate of reaction will increase at high temperatures. So this corrosion is due to chemical action of flowing liquid metal at high temperatures on solid metal or alloy. So this corrosion reaction involves either diffusion of this solid metal by a liquid metal, or in internal penetration of liquid metal into solid metal. So for example, if we have a metal and there is a drop of mercury here, so it will slowly penetrate into the metal and corrodes. It forms metal amalgam. So amalgams. So for example, liquid metal mercury dissolves most metals by forming amalgams and thereby corroding them. So these are some of the examples for dry corrosion. So there is a rule called filling Beckwith rule that gives a ratio. So this depending on this ratio, we can understand whether the metal oxide layer is porous, non-porous, or having any cracks, so on. So it is the ratio of volume of metal oxide formed to the volume of metal consumed. So it is a simple logic, like there is a metal and there is a corrosion product that is formed on the metal. So this is the consumed metal. So it is the ratio of volume of metal oxide formed to the volume of metal consumed. If for example this area is the metal consumed and this area is the volume of corrosion product, volume of corrosion or the metal oxide form. So this will clearly give some ratio, that is which indicates the porosity of that particular metal. So it is given in the form of equation: volume of metal oxide formed by volume of metal consumed. This is the pure metal. So its ratio will give an understanding. So if PBR is less than 1, if the Pillsbury rule is less than 1 ratio, if this ratio is less than 1, it is porous. If it is less than 1, it is porous. We can understand that it is porous. If it is greater than 1 but less than 2, if it is greater than 1 but less than 2, less than 2. Then it is non-porous and protective. Then the metal oxide layer is non-porous and protective. If it is greater than 2, if the PBR ratio is greater than 2, then it has some cracks and do not protect. So depending on this, for bench experiments, we can understand that before applying that metal to any large scale applications, we should take these ratios here consideringly like that, so that we can understand the nature of that metal oxide. Nature of metal oxide. So that we can vary the material and then go for the applications. So with that, we have completed like second theory of corrosion. Then we will jump into the galvanic or electrochemical or wet theory of corrosion. So when metals are exposed to air, moisture, soil, etc., then they undergo corrosion through electrochemical process. So what happens when it is exposing to air, moisture? It is giving some medium for the metal to react. So it forms some anode, cathode, electrode like areas, so that electrochemical reactions will take place like oxidation and reduction. So this is nothing but electrochemical theory of corrosion. So we will understand in detail why and how it will happen. So in this process, separate anode and cathode areas are formed on the metal surface. So this is what we are trying to understand. For example, here if we see in this image, moisture is there. This is the metal. The white part is the iron metal, for example, and there is some moisture on that. So with this moisture, there is a formation of anodic area and cathodic area. Anodic area and cathodic areas. So these anodic and cathodic areas will create electrochemical cell. So that is giving rise to electrochemical corrosion. Corrosion always occurs at anodic areas of metal through oxidation and releases electron. At anode always oxidation takes place. As we know, at anode always oxidation takes place. When oxidation takes place, it releases electrons. So these liberated electrons from anode, will move to the cathode. Where reduction occurs. So this is how the theory will go on, and overall reaction is electrochemical reaction giving rise to electrochemical theory of corrosion. So this is also known as wet theory of corrosion because it is occurring in the presence of moisture. It is takes place in the presence of moisture. So called wet theory. So we have to understand by the name itself, like galvanic or electrochemical or wet theory of corrosion. Wet means moisture. So it undergoes the corrosion in the presence of moisture. So we'll see what is the mechanism of wet corrosion, that is the galvanic or electrochemical corrosion that is taking place. So it takes place in the environment where the humidity is exceeding 60%. So whenever there is a huge moisture present on the surface of metal, then the humidity increases. So when it is increasing humidity, there is ultimately leading to corrosion. So for example, here is the anode and cathode reactions of iron metal. So anodic reaction and cathodic reaction. For example, what happens at anode? Oxidation. So for example, in this figure, if we see, this is the anode area. So what happens? The iron will oxidize to Fe2 plus and 2 electrons are released. So dissolution of metal takes place. As a result, metal ions are formed with the liberation of free electrons. So with the liberation of 2 electrons. So these 2 electrons will go to the cathode. How? So there are some mechanisms how the cathode will accept the electrons. So hydrogen evolution and oxygen absorption. So occurs usually in acidic medium. When does the hydrogen evolution takes place? When there is acidic medium. When the reacting medium is acidic. In nature. Then H2 gas will be evolved. As a result, metal ions are formed with the liberation of free electrons. So these two electrons are accepted by the H plus ions present in the acidic medium. H plus ions present in the acidic medium and gives rise to hydrogen gas. Then the oxygen absorption. It occurs when solution is aerated sufficiently. So, if, for example, if there is a moisture that is causing electrochemical reaction and it is also having the feasibility of presence of oxygen, then oxygen absorption will dominate and forms oxygen absorption will occur, and that is the reaction that takes place at the cathode. So, if the oxygen is present in both the environment, like acidic and basic medium, then what happens? The oxygen will accept these electrons in acidic medium, water; in basic medium, hydroxyl ions. This is how the reaction mechanism takes place. So, as we see from this figure also, these Fe2 plus ions, these two electrons are again accepted by the H plus ions present in the cathodic region, and hydrogen gas is evolved. So in detail, if you see the mechanism of this hydrogen evolution, which is occurring in acidic medium, at anode this iron is oxidizing to Fe2 plus and 2 electrons are released. So diffusion of Fe2 plus into, so this is the anodic area and this is the large area of anodic surface. Then this forms the cathode. So this is a corrosion product. This is the medium, solvent or medium. So the hydrogen ions are formed due to acidic environment. So due to acidic environment, hydrogen H plus ions are formed and following reaction occurs. So these 2 plus ions, H2 plus ions will accept these 2 electrons and gives rise to hydrogen gas. So the overall reaction is like iron and these 2 H plus ions will give rise to Fe2 plus ions and H2 gas, hydrogen evolution. This is how the hydrogen evolution will take place. This type of corrosion causes due to displacement of hydrogen ions from the acidic solution. Because we are utilizing this H plus ions from the acidic electrolyte. All the metals above hydrogen in the electrochemical series have tendency to get dissolved in the acidic medium with hydrogen evolution. So if we see the galvanic series, all the metals which are present above, which are highly reactive, will dissolve in acidic medium, giving rise to H2 gas. Then oxygen absorption. Let us see the mechanism of wet corrosion by oxygen absorption. So the rusting of iron takes place in neutral. When it is in neutral pH, the aqueous solution of electrolytes such as with presence of atmospheric oxygen. So if the metal surface develops cracks, so if there are some cracks, obviously there is a scope for the oxygen to penetrate into the metal and cause corrosion. So anodic areas are created on the surface, whereas metal parts are cathodes. So this is the cathodic area which is protected. This is again protected area. Anode, poor access to oxygen. So anode, poor access to oxygen. So what happens wherein there is a good access to oxygen? There is penetration of oxygen into the metal. What happens at anode? This Fe plus this iron will oxidize to Fe plus 2 ions and 2 electrons are released. So the released electrons from the anode will go to the cathode through iron metal. The released electrons will go to the cathode through metal. Through metal. So at cathode, what happens? The oxygen and the moisture, whatever is present, will accept these 2 electrons and form hydroxyl ions. So this will give rise to some precipitate. This precipitate is formed when this Fe2 plus ions will combine with hydroxyl ions. So this Fe2 plus ions will combine with hydroxyl ions and gives rise to iron hydroxide. So when there is excess of oxygen, so when it is keep on reacting with the oxygen, then it will continue the reaction and form yellow rust, which is like ferric hydroxide from Fe plus 2 to plus 3 and hydroxide forms ferric hydroxide. This is the ultimate rust that is forming on the metal. So as we see from the figure, this is nothing but the rust ring, rust that is forming on the metal surface. So in electrochemical reactions, corrosion, there is two types. There are again two types of corrosion that are taking place depending on the metals that are reacting. So differential metal corrosion or galvanic corrosion, differential aeration corrosion or pitting corrosion. So what happens in the differential metal corrosion? There are some different metals that are placed together. So different metals when are kept together, this differential metal or corrosion or galvanic corrosion takes place. So these dissimilar metals are in contact with each other. The metal with lower electrode potential becomes anodic. Lower electrode potential will become anodic. Anodic is oxidation again. Remember this, anode oxidation, and undergoes corrosion. Nothing but corrosion. This oxidation is nothing but corrosion. Metal with higher potentials become cathodic and remains unaffected. So at higher electrode potential, it is cathodic. Higher electrode potentials, it is cathodic and doesn't affect. The rate of corrosion depends on the difference in the potential between these two metals. So when two metals are kept together, the difference in electrode potential is also very important. So depending on that only the corrosion rate also depends. Higher the difference, the faster is the corrosion. Higher the difference, faster will be the corrosion. For example, if it is sodium, which is highly reactive and placed in top of the series, and oxygen below this will have high rate of corrosion. So here is another example, like iron, the steel and copper are kept together. So this Fe2 plus ions are forming from the steel, and these two electrons are consumed by copper, consumed by the hydroxyl ions present in the atmosphere, like solvent that is present in between and gives hydroxyl ions. So ultimately what is corroding here? Steel is corroding here, iron is corroding here. As you know, iron is above the copper. So example for this, as I told, like standard electrode potential of iron is minus 0.44 volt. Iron is minus 0.44 volt. Then what is for copper? Copper, it is plus 0.34 volt. Therefore, when iron comes in contact with copper, iron becomes anodic. So when it is coming in contact with copper, iron becomes anode and copper becomes cathode. And copper will be unaffected, whereas iron gets corroded and due to corrosion that is taking place. So these are the reactions at anodic area and cathodic area. The other example is when, for example, these are positive and negative, we can understand that this is less and copper is more. When it is like, for example, when both the electrode potentials are negative, so zinc is minus 0.76 volt, and iron is minus 0.44 volt, minus 0.44 volt. So when iron is in contact with zinc becomes anodic, and and undergoes corrosion. Higher negative is always less, so zinc becomes anode. See here, zinc becomes anode. This Zn will give rise to Zn2 plus and these two electrons. So this is anode, oxidation is taking place, it becomes an anode and corrosion occurs. And the cathode, the iron is unaffected. So here from still Previously we have seen always like iron is corroding, but when there are two metals like iron and zinc, depending on their electrode potentials, zinc will be corroding here and iron is unaffected. The same is shown here in the diagram. See, zinc Zn2 plus oxidation is taking place and 2 electrons, and iron is cathode, reduction taking place and forms water. So zinc is corroding. What is differential aeration? The other type of electrochemical corrosion is the differential aeration or pitting corrosion. So what happens here, when a metal is exposed to different concentration of oxygen, we are always saying that oxygen will react, but when there is different concentration of oxygen, for example, this car tires, the metal that is present around the car tire will have different concentration of oxygen while running. So there is more and less areas that is forming. So what happens, we will see. The part of metal which is more exposed to air will act as cathode. So when it is more exposed, for example, beneath this tire it is more exposed to air or the oxygen. So it is forming cathode and remains unaffected. But the other part of the metal which is less exposed to air acts as anode and undergoes corrosion. So this is less exposed to air or oxygen and forms anode. So oxidation will take place and corrosion occurs. And the other good example is the pavement that is seen in this figure. The differential aeration occurs when a portion of piece of steel stays wet longer while the rest of the piece is dry. This is dry, and beneath it is wet. So the intermediate zone, this zone is the intermediate zone that will undergo corrosion. So that is how at some places there is bending of that poles or breakage of the poles or cracks at these junctions or the interfaces due to corrosions. So there is another type of corrosion like waterline corrosion. In the differential aeration corrosion, there are other types of corrosions like waterline corrosion. It means when it is in contact with water. For example, in this bridge, if we see the metal is in contact with water, so this is water and this is metal. There is some difference in the corrosion. So we will see how it is occurring. During waterline corrosion, the part of metal below waterline is exposed to less oxygen. So this which is in the water will expose to less oxygen and becomes anode, undergoes corrosion. So when it is below, for example, in ships also, for example, if we see till here the water, it is dipped in water, so it is less exposed to oxygen. The oxygen concentration is less, so it will act as anode and corrosion occurs. Which is the other part, the outer part of the top portion is more exposed to atmospheric oxygen and acts as cathode, forming cathodic reaction takes place. We will see what are the reactions that are going on. So if we see schematically, this is the water jar. So if there is a penetration of oxygen, so this forms cathodic area. So this is the corroded part that is submerged in the water and forms anodic area. This formation of anodic area causes corrosion. So at anode, what happens? The iron rod which is dipped in water will undergo oxidation, like forming Fe+2 ions and 2 electrons. It gives rise to 2 electrons. At cathode, what happens? These 2 electrons that are released here will go to the cathode and react with the water, accepts these 2 electrons, it reacts with the oxygen, water, and forms hydroxyl ions. So this is the mechanism that occurs in the waterline corrosion. Then we will see what is pitting corrosion. What is pitting corrosion? For example, it occurs when small particles like dust, mud, etc. deposited on metal surfaces. For example, if there is a metal surface, this is the iron metal that is present, and this is the dust particle that is adhering on the metal. So the portion of metal covered by the dust or the particles is less aerated. Due to presence of this dust on the metal will avoid the penetration of oxygen into the metal, so it is less aerated, nothing but air, passage of air, less aerated, and forms anode. So anode. This forms anode. The other portion of metal exposed to more oxygen of the environment acts as cathodic region. So this metal is exposed to more oxygen and forms cathodic area. So corrosion takes place at portion below the dust and small pit is formed. So there is a corrosion taking place below these dust particles, and the corrosion will occur here, forming a pit. A hole like thing is forming. It is not a complete hole, it is forming a pit. Pit is forming due to corrosion. Then the rate of corrosion increases due to small anodic area and large cathodic area. So when there is small anodic area, this anodic area is small. For example, if this is bigger, when there is a large metal area, the anodic area will be smaller. So due to this difference in anodic and cathodic areas, the rate of corrosion will drastically increase and the corrosion will take place. So these are the reactions. The iron will oxidize to Fe+2 and 2 electrons are given, and at cathode these two the electrons that are released will be consumed by the oxygen and water, forming hydroxyl ions. So this is pitting corrosion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.